Okay, students, now I'll talk about important thing, but you need to understand it in simple way. We will talk about the motion of center of mass. Okay, we know that the position vector of center of mass, name it d as a vector, is equal to the position vector for the first mass multiplied by the mass plus the second position for the second mass, and so on, multiplied by the mass, divided by the total masses. This is equal to the position of center of mass in x direction, which is x1 multiplied by the first mass plus x2 multiplied by the second mass, and so on. And also the position vector, which is dy, and I name it d is equal to x hat plus y hat, or dx x hat dy y hat. This is the vector position d. And the position vector in y direction for the center of mass is equal to d1 y for the first body multiplied by the first mass, and the position in y direction for the second body multiplied by its mass divided over the capital mass m. Okay, now this position vector, the change in position, if we divide it on the time, we know that will give us the velocity. So if we have two bodies and their position, this is xy plane, this is the position, the center of mass is on the line between them. I will take just two bodies, I can take three. Hi, this is third body m3, okay, and this is the center of mass. I'll take this is the center of mass, and this is the vector d center of mass. Okay, if all of these bodies are moving during a time, then this d will change from position 1 to position 2. Then we have another d for the three bodies. The change in this position divided, the change in position divided in time, it will give us the velocity. We know that velocity is equal to delta d over delta t. D is the position. Okay, so we can find the velocity of center of mass. Also, if we find that the velocity is changing with time, then this center of mass for these bodies are accelerated. If we have just one body and it is under free fall, we know that the free fall downward is equal to g, which is minus 9.8. What if we have two bodies and all under free fall? The center of mass between them is also accelerated with them. The system altogether is accelerated to the position of the center of Earth, which is the direction of g. So we have an acceleration for the center of mass, which is the change in velocity vector with respect to time. Okay, now we need to know that we have position vector for distance for a center of mass, a velocity vector for center of mass, and acceleration vector for center of mass. Okay, now for velocity vector, it will equal to the first mass multiplied by its velocity plus the second mass multiplied by its velocity, but as a vector, because its velocity may have component in x and y. Maybe this is v1, this is v2, this is v3, and so on. So it is the summation of the mass multiplied by the velocity, each mass by its velocity vector, divided by the total mass, which is the summation of all masses. And the velocity vector for the center of mass uh, depend on the velocity for the first body. The velocity of first body, as we put here, has an x component and y component. The second body has an x component and y component, and so on. Okay, now the second body is the same, has its velocity has two components, one in x direction and one in the y direction. For the acceleration also, we have the acceleration of center of mass is composed or depend on the acceleration of each body. So the first body mass multiplied by its acceleration vector plus the second body mass multiplied by its acceleration vector, and so on, divided on the total mass, which is m capital. So this is the summation of m by its velocity. This is the acceleration of the system center of mass. Okay, and for each body, its acceleration is composed of x component acceleration and y component acceleration for each body. Okay, now if we know the acceleration, we need to compute another thing. Let us look at this system. We have four bodies, for example, m1, m2, m3, m4. Assume that this is the center of mass of them, and the center of mass of them is accelerated. This is the acceleration of the center of mass. All of these objects are moved together in the space. Assume them a planet and its moons, okay? And each body of them, maybe they are asteroids. Each body of them, each mass of them has its acceleration vector. Look at this one. M4 has its acceleration vector in this direction. Maybe its magnitude more than the others. This is the first body acceleration vector, and this is for the third, and this is for the second body. Okay, the acceleration for the center of mass is the summation of each, as we told you before, the summation of first body mass multiplied by its acceleration vector, the second body mass multiplied by its acceleration vector, and so on, divided over total mass, which is m capital. Look at this. This is the force on the first body. This is the force on the second body, and so on. What if we multiply the total mass by the total acceleration for the center of mass? This is the total mass multiplied by the acceleration of center mass is equal to the summation of all forces on each body. Okay, so this is m capital multiplied by the acceleration of center mass. We assume that all of the system masses combined in just one m capital, and all of this m capital is accelerated in one acceleration value, which is a center of mass. This we can call it the net force, which is the net external forces on the system. We have these four asteroids. All of them are under the gravity of the sun, for example. So all of them will have center of mass acceleration. And these terms, the summation, is the net forces on the system components. Okay? So we can understand that if external, or the external force, or the external net force is equal to the total mass of the system bodies multiplied by the acceleration of this system. Let us take this example. We don't need to draw anything. We have three bodies, M1, M2, M3, 5 kilograms, 3 kilograms, 10 kilograms. And the acceleration vector for each one of them as given. This is -2 in x direction plus 5 in y direction. This is 0 there is no acceleration x direction for the second body, and this is the acceleration for the third body. Find the external force on this system. Look here for the first body. Its acceleration in this direction, it is -2 in x direction and +5 in y direction. It seems to be in this way. The second body acceleration, it's -10 in y direction. It is in this direction. I don't know the configuration for the three bodies, but I'm here just to show you the accelerations on each body. This one is also 5 in x direction and 15 in y direction. Maybe it will be in this direction, okay? The acceleration. Okay, if external, what I need to compute it, has two components, fx in x direction and fy in y direction, because it is a vector. This vector has two components. Okay, let us compute fx component. Fx is equal to the total mass multiplied by the acceleration in x direction for the center of mass, okay? Which is equal to the summation of each mass multiplied by its acceleration in x direction. Now I just take the x direction, the y direction, and compute each one alone. So each mass is known, is 5, 3, 10, 5, 3, 10, and the acceleration in each direction, in x direction for each body is known also, -2, 0, 5, -2, 0, 5. The total force acting on that center of mass is 30 newtons. Positive 30 newtons, that means the direction of x in x, positive x direction, okay? What about the y component of the external force? It is the mass of the center of mass, the mass of the total mass of this system multiplied by the acceleration. And the mass of each body is known. The acceleration in y direction for each mass is known. It is 5, -10, +15. So the F in y component for center of mass is equal to -105 newtons. Negative means in negative y direction. But the x force is in positive x direction. So the net force is equal to 30 in x direction minus 105 in y direction. I can find the angle by using tan inverse of -35, negative 105 over 30. Okay, I can find the acceleration of center of mass. Just I need to divide the force over the total m. This will give me the acceleration. Okay, this is the example on the motion of center of mass. Thank you.